So a tank has a height of 10 feet. The area of the horizontal cross-section is given by the function A, measured in square feet. The function A is continuous and decreases as h increases. And here we're given values of A of h. Alright, so first part it says to use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the volume of the tank. Indicate units of measure. So we are looking for the volume here. Remember, Riemann sum is area of rectangles. So I have to do the width times the height. The width in the first case is 2 times, if it's a left Riemann sum, I take the left endpoint, 50.3, plus the next width is 3, 14.4, plus the next width is 5 times 6.5. So I ended up using, 3 of those, the first 3 of those. And remember, we leave 1 out for Riemann sums. And so this is 176.3 cubic feet. Okay? 2 points here, setup and value. Does the approximation in part A overestimate or underestimate the volume of the tank? Well, if this is a decreasing function, and we're doing a left Riemann sum, then this is going to be an overestimate, right? Right? So the way you're going to write it is A of h is decreasing and a left Riemann sum will be an overestimate. So it turns out this is a theme in this year's the 2017 AP for some reason, because they ask it again later. Alright, here this is just 1 point. The area in square feet of the horizontal cross sections at height h is modeled by the function given by f of h. Based on this model, find the volume of the tank, and here all we need to do is say volume is the integral of f of h dh. Be careful of the variable there, right? If it's f of h, then you want to do dh. And what are the units? From the bounds are from 0 to 10. Because this is a calculator question, this is all you need to show, and then just the answer, which is 101.325 cubic feet. So that's part C. Part D. Water is now being pumped into this tank. When the height of the water is 5 feet, the height is increasing at a rate of 0.26 foot per minute. So that's dH dt. Using the model from part C, find the rate at which the volume of the water is changing with respect to time. So we need to find dV dt when the water is at 5 feet. Okay? Alright. So, dV dt is what? Right. So what we have to do here, before I do dV dt, first of all, what was the volume here? the volume. If this is if F is the area of the cross section, right?
The integral of that.
If this is the volume, right? Then what I want now is dv dt. So basically, I need to find an integral of this. I'm sorry, a derivative of this. That's the fundamental theorem of calculus. If I want to find the derivative of that, right, then what is it? Is it f prime or is it f? It's f of h times dh dt. Okay? So that's going to be 50.3 over e to the 0.2h plus h times dh dt. And this is going to be evaluated when h is equal to 5. So it's 50.3. You don't have to show the, you don't have to show plugging that in. You can just plug it in your calculator. So e to the 0.2 times 5 plus 5 times 0.26. And that is 1.694 cubic feet per minute. Okay? You get 2 points for the correct for that line, f of h dh dt. Right? So there are different variations of. Somebody might say f prime of it. Somebody might say just f of h. Somebody might say, you'll forget the dh dt. There are so many different things that could look like. And then you get 1 point for this answer. And in this question, they gave one collective point for all the units in parts A, C, and D. And that means if you gave units in 2 of the parts, but not in the 3rd, you don't get that point. It's an all or nothing deal.
That's no.
Okay. D, 2. Oh, it's the banana. Okay. When a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by this. So this is the rate at which it's being removed, where F of t is measured in pounds per hour, and t is the number of hours after the store is opened. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by this. So this is the rate at which bananas are being added. So notice f of t is valid from 0 to 12. G of t is only valid from 3 to 12. So if somebody were to come in the first 30 minutes and take all the bananas, nobody is going to add any more until hour number 3, presumably, okay? Okay. G of t is measured in pounds per hour, and so on. How many pounds of bananas are removed during the first 2 hours? And for this one, all you have to do is to show that this is from 0 to 12 of f of t dt. That's it. And then plug it in your calculator
0 to 12 or 0 to 2?
and get the answer 2. And get the answer, which is 20.051 pounds. Part B says, find f prime of 7. Using correct units, explain the meaning of f prime 7 in the context of the problem. So, f prime of 7, you're going to do a numerical derivative in your calculator, and all you have to show is that it's negative 8.120. So, numerical derivative on calculator. Okay? Now, the important part is, there's one point for that only. The important part is explain the meaning of f prime of 7 in the context of this problem. So basically, this is the rate at which bananas are removed, right? 7 hours after the store has been opened. And now you can go a little bit further and you can say 7 hours after the store opened, right? The rate at which, so what is this? F prime, F was the rate. F prime is the derivative of the rate, right? So this is the rate of the rate. So the rate at which bananas are removed is decreasing at a rate of 8.120 pounds per hour Okay? You see that? That's an important part. So the rate that they're being removed is decreasing at a rate of 8 pounds per hour Okay? So if in the first hour, like 6 pounds per hour are being reduced, now it's like 8 pounds less, let's say. Okay. Part C is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5. Okay, so what is the expression for the number of pounds of bananas actually on the table? We have the rate that they're being added, the rate that they're being removed. What's the difference between them at t equals 5. So basically what this is g of 5 minus f of 5. And both of these, you do it with your calculator. So the best way to do this is to store, to store these on your computer in one. Store the first function in F1, store the second function in F2, and then in your home screen you could do G of 5. I'm going to add a page here, right? So I'm going to do Control, add a page. Let's add a calculator. And what is it that I was trying to do? I was doing G of 5 minus, okay, so G in here is now F2 of 5, right? You just have to keep that in mind. So it's F2 of 5 minus F1 of 5. And that is negative 2.263. Okay? So that's how you can do that. So this is negative 2.263. Okay, so we say, it says, is the number of pounds increasing or decreasing. So you say this is less than 0. So you say since g of 5 minus f of 5 is less than 0, the number of pounds, don't abbreviate right now, of bananas is decreasing. Okay. D. How many pounds are on the table at t equals 8? So that's going to be the initial amount, which was how much? 50, plus the amount that was added, g of t, and that goes from 3 to 8, minus the amount that was subtracted, not subtracted, but removed. Okay? And so now when you run your calculator, you're going to do the same exact thing. So you can even do like 50 plus in here, this one, right? What was it? From 3 to 8? 3 tab, and this one was F2, correct? Okay. dx, and then you do plus this, and you do plus, and then you have to do another integral. Right? But this time you do F1 from 0 to 8 and so on, and the answer ends up 23.347 pounds. Okay? 2 points was given for this, 1 pound for the 1.1 pound. 1 point for this. This was 2 points, so 1 was for that, 1 for that. Value, 1 point, meaning 1 pound. I keep saying pound. And then here 1 and 1. Is that 9? That should be 9. Alright, question? Okay. Oh, look at one of these. I love Okay, function f is differential on the closed interval -6 to 5, satisfies the equation. F of -2 is 7. It's differentiable. The graph of f prime consists of a semicircle and 3 line segments, and that's what we're given. We're given f prime. Find the values of f of -6 and f of 5. So if I have f prime and I want f, I need to integrate. So f of -6 is equal to f of -2, right, plus the area from -2 to -6 of f prime of x dx, right? And so that means this is f of -2 is 7 minus from -6 to -2 f prime of x dx. Okay? So, as far as area is concerned, if I went from -2 to -6, this one is 1/2 times 2 times 4. So that's 7 minus 4, and that's equal to, right? So it starts off pretty basic, but now already that we've seen this sort of integral where you have to change the bounds because it's going in the reverse direction. So now part B1, the intervals over which f is increasing. Oh, f of 5 as well. f of 5 is f of negative 2 plus 2 to 5 f prime of x dx, and there's no need to switch anything over there. So here we have 7 plus, or negative rather, the area of that semicircle is half times pi times 4 plus the area of this is half times 3 times 2. So all that is 10 minus 2 pi. Okay? Okay. Part B. On what intervals is f increasing? What does it mean for f to be increasing? The derivative. Okay, so we say f increases when f prime is greater than 0. Okay? And so we say the interval where that happens is negative 6 to 2. No. Because that's where the derivative is above the x-axis. Negative 6 is an endpoint, so we close it. Okay? And leave it open there. And 2 to 5. 2 to 5, right? Because at 5 the derivative is 0. So, but at 5 the derivative is 0. It's not positive, it's 0. Okay? At negative 6 the derivative is strictly positive because it's above the x-axis. At 5 the derivative is strictly 0, neither positive nor negative. Okay, C, what does C ask? Find the absolute minimum value on the closed interval. That's extreme value theorem, right? Negative 6 to 5.
It can give you the value for negative 2, which will be 1 at the point for the
yeah.
But you do it for that gives you the
point. You have to find them. Yeah, you have to find all of them. So C, okay, here's what we have to do. If you want the absolute minimum value, first you need to find the critical point. So you say f prime of x is 0, where? At negative 2, positive 2, and 5. So at plus or minus 2, at x equals plus or minus 2 and 5. So now, you need to find f of negative 6, f of 5. Hey, we've already found those in part A, right? F of negative 2, they give you that. F of 2 is really the only one you have to find all over, like fresh. F of negative 6 is 3. 5 is 10 minus 2 pi. F of negative 2 you're given is 7. F of 2 is 7 plus from negative 2 to 2, f prime of x dx. So that's 7 minus 2 pi, and that's it. So now, what is it that we're looking for? Absolute minimum value. Which one is this? So this is a 3, this is a 7. Here we have 10 minus 6.28. That's about a 4. 7 minus 6.28, that's the lowest. Okay? So absolute minimum value is f of 2, which is 7 minus 2. Isn't that a fun little problem? Okay, this is a good one. Let me do some point values here. So, 1 point for this, 1 point for this, and 1 point for using that initial condition. Okay? Yeah. Just show it. Okay? Here, you get 1 point for, like, the critical point. 1 point for, like, all of the rest. For each f double prime of -5 and f double prime of 3. Find the value or explain why it does not exist. So at -5, where is -5? Here. Right? What's f double prime? What does it mean, first of all, like conceptually, f double prime? It's the slope of that graph. Okay, so there's no issue there, right? Because the slope of that point, at that point, is just the slope of that line segment. So that's pretty simple. So let's go ahead and find that. So for D, f prime of 5 is equal to, what is it? So you do 2 minus 0 over x minus 4, so -6 minus -2. How much is that? -1/2. Yeah? Okay. What about the slope at x equals 3?
That's also just the slope of the line segment.
At x equals 3?
X equals 3.
What is the slope? Find it. What's the slope at x equals 3? Okay, so what are you going to do? Are you going to find the slope of this line? Or are you going to find the slope of this line?
Well, it's differentiable.
Is it?
It's continuous and differentiable on the entire closed interval of -6 to 5.
So what's...
So being differentiable means...
What is differentiable?
The function f.
Right, but what is this?
It's not. So it doesn't exist because it's a corner.
It's a corner, but you can't say that. That's what were you saying?
You can't say that?
The limit is what you... Okay, so what you have to say is... you have to find the slope of the left, you have to find the slope of the right, and you have to show that they're not equal to each other. So, the limit... Okay, so what is the definition, the formal definition of a limit? I'm sorry. No. Yeah, what is the formal definition of a derivative? It's the limit as x approaches a value, 3 minus, of f of x minus f of a over x minus a, right? Is that the formal definition of a derivative? F prime, I'm so sorry. F prime, because we're looking for f double prime. So this is the formal definition of the derivative of f prime. The limit as x approaches a, f prime of a minus whatever, okay? So this is equal to 2. The limit as x approaches 3 from the positive side, f prime of x minus f of 3 over x minus 3 is equal to -1. Okay? So, the first one is the slope of the road. The second is the slope of the blue. Clearly, those are not equal to each other. So you can basically say that the limit of x approaches 3 minus, just say the whole thing again, f prime of x minus f prime of 3 over f prime of 3 is not equal to the limit of x approaches 3 plus. These are all primes. Okay? Therefore, f double prime of 3 does not exist. It's kind of sneaky how we put that in there, but it's not at the same time. Yeah? Okay. Oh, and now the boiled potato. Alright, who wants to be my reader for the boiled potato? Who's reading for me? Exactly, why don't you read?
I like the idea of going something again.
Zachary, we only have 60 minutes.
When t equals 0, boiled potatoes taken from a pot on a stove and left to cool in the kitchen. The internal temperature of the potatoes is 91 degrees Celsius. Greater than 27 degrees for all times t greater than 0. This potato at 90 minutes can function h that satisfies the differential equation that where h of t is measured in degrees h of 0.
Okay, write an equation for the line tangent to the graph of h at t equals 0, right? So basically, all I need is the equation of the line, equation of the tangent line. So, and then use your equation to approximate internal temperature. So again, linear approximation, right? So, for the equation of the line, I need a slope and a point, correct? So what's the slope? H prime at 0 is, how much is that? Negative 1 over 4. Right? -91 - 27. And that's actually negative 16. So that's the slope. Okay? I need a point. What's the point? H of 0 is equal to 91. So if I wanted to write the equation, it's y minus 0. Oh, I'm sorry, y minus 91. So it's basically y equals 16 negative 16 t. So y is negative 16t plus 91. Okay? And now at time t equals 3, y of 3 is equal to negative 16 times 3 plus 91, and that's equal to 43 degrees Celsius. Okay, so here you got 1 point for the slope. That's surprising. 1 point for the tangent line and 1 point for the approximation. Alright? Use d squared h dt squared to determine whether your answer in part A is an underestimate or an overestimate of the internal potato temperature at t equals 3. So, we estimated that this is 43 degrees. So is this an underestimate or an overestimate? Well, what is d squared h dt squared? Let's just find that first. That's equal to negative 1 over, so it's the derivative, right? Look at dH dt. If I distribute the 1/4, I get negative 1 over 4h plus a constant. So the derivative is negative 1 over 4 dH dt. Right? But what is dH dt? It's negative, so this is negative 1 over 4 times negative 1 over 4 h minus 27. Right? So really, this is 1 over 16 h minus 27. Okay? Now, what were we told here about h? H of 0 is 91, right? And then at 3, what were we told? Oh, no, here. This is what I want. The internal temperature of the potato is, so H is greater than 27. For all times t greater than 0. Right? So, that's H. H is always positive. So now this is d squared h dt squared. So since h is greater than 0, okay, d squared h dt squared is also greater than 0. Correct? Oh no, wait, that doesn't make sense. No, hang on. No, 27. So since h is greater than 27, right? D squared h, when you plug 27 for h here, d squared h is going to be positive, right? What does it mean when the second derivative is positive? It's concave up. But also, what about dh dt? What about dh dt? It's what? Is it positive or negative? Negative, right? Because negative 4, blah, blah, blah. So part B, d squared h dt squared is greater than 0, which means it's concave up. Okay? dh dt is less than 0, which means it's decreasing. Right? That doesn't really matter as much. So now, what about the tangent line approximation? So if I have a graph that's decreasing and concave up that looks like this, what does the tangent line look like? Here, it's just under, right? Right? So you don't have to show the drawing, but like concave up, decreasing, therefore, you know, it is an underestimate.
Is it okay that we do the dots as therefore?
That's okay. Yeah. Okay? Okay. So, C says, for T is less than 10, an alternate model of the internal temperature of the potato is the function g that satisfies the differential equation dg dt. G of 0 is 91. It has to be. Find an expression for g of t. So this is differential equations, separation of variables, and all that good stuff. So C, if dg dt is negative g minus 27 to the power of 2/3, then dg over g minus 27 to the power of 2/3 is equal to negative dt. Integrate, integrate. So here's what I'm going to do here. G minus 27 to the negative 2/3 dg is equal to negative t plus c. How do we integrate this one? So g minus 27 to the power of 1/3 times 3 is equal to negative t plus. Okay. Let's put in our initial condition at t equals 0. G is 91. So 3 times 91 minus 27 to the 1/3 is C. 3 times, this is 64 to the 1/3 is C. So C is 12. Right, so what does that mean? 3 times G minus 27 to the 1/3 is negative t plus 12. What's that? Divide by 3. Take a raise it to the power of 3. I'm going to write this as 12 minus t. You know how I feel about those dangling negatives. To the power of 3. So G is 27 plus all of that mess. Oh boy, that's not even the answer. What else do we want? Internal temperature at G of... You know what, here? Let's label G of t, not just G. So what's G of 27? Max says it's 54 degrees Celsius. So, this part C was worth 5 points. Yep. There's always a point for proper separation of variables. There's always a point for proper antiderivatives. Always a point for using the initial condition and getting that C. Okay? Writing an equation for G and T here, basically, and then these two together are another point. No, that's not this one.